Welcome back to chapter 32, Structure Determination, section number 2, Proton NMR. By the end of this video, you will be able to explain a proton NMR spectrum, describe what information a proton NMR spectrum gives, and explain what the integration trace shows. Let's discuss proton NMR. In proton NMR, it is the nucleus of the hydrogen that is being examined. Nearly all the hydrogen atoms in this proton, they are easier to get NMR spectrum more than the carbon NMR. This is an example of a compound that we might examine its structure, and here it is ethanol. Here it is the hydrogen atoms attached to different functional groups that feel the magnetic field differently. So when I put my sample inside the test tube, the hydrogen atoms are the atoms that feel the magnetic field I expose them to. Because all nuclei are shielded from the external magnetic field by electrons that surround them. If you look here, we can see that there are some nuclei with more electrons around them, and which means they are better shielded. The greater the electron density around a hydrogen atom, the smaller the chemical shift. So if we look here at an example of a proton NMR of ethanol itself, these three hydrogens that you see here and here, in this drawing it's in blue. These three hydrogens, they are around one carbon. So we have three hydrogens surrounding a carbon. So these hydrogens have high electron density around them. So you will expect for these three hydrogens to have a smaller chemical shift. And as you can see here, the chemical shift of these hydrogens are the nearest to the zero. They are around 1.4. And the values of chemical shift in proton NMR, they are smaller than those in carbon NMR, and they are mostly between 0 and 10. So in the carbon NMR, we used to have chemical shifts around 200. Here, the chemical shifts, they only range between 0 and 10. In a proton NMR, if all the hydrogen nuclei in an organic compound are in identical environments, which means they are in the same environment and they are in the same group, you get only one chemical shift value. For example, all the hydrogen atoms in methane, CH4, they are in the same environment and they have the same chemical shift. The four hydrogens, they are all attached to one carbon. They are all in the same environment. So they will give us one chemical shift. As you can see here in this proton NMR, this belongs to the CH4 methane. You have only one peak around 0.4. Now, what if not all of the hydrogens belong to the same environment? If the hydrogen nuclei in a compound, they are found in different environments, you will not get one chemical shift anymore. You might get two or more than two different chemical shifts. An example here is methanol. There are hydrogen atoms in two different environments. As you can see here, they highlighted them on the drawing. The three on the carbon atom, and we have the one on the oxygen atom. The NMR spectrum will show the two environments, as you can see here. So, the three hydrogens, because they have high electron density, they have smaller chemical shift, where you see here. And this one next to the oxygen, it has a chemical shift at 1. In general, the further away a hydrogen atom is from an electronegative atom, such as oxygen, the smaller its chemical shift. Example here again, the three hydrogens, they are away from the oxygen. That's why they have a smaller chemical shift than the other hydrogen. In ethanol, like CH3, CH2OH, there are three values, for example, and so on. It depends on the chemical compound we have.